how many of you have heard of interpretations of quantum mechanics? Yeah, so everyone's heard of the Copenhagen interpretation? So the Copenhagen interpretation is due to, or supposedly due to, Niels Bohr. And I guess when, in the early days of quantum mechanics, Niels Bohr was at Copenhagen, and this was a big center of research in quantum mechanics. And a lot of physicists came through and, well, were maybe taught quantum mechanics by Niels Bohr. Anyway, much later, David Mermin started teaching a course in quantum computation at Cornell. And he writes, he's a physicist, but he also occasionally writes philosophical columns for, I think, Physics Today. And one of his columns, he said, starting to teach quantum mechanics to all these computer scientists, I found myself drifting into the Copenhagen interpretation. And Niels Bohr, of course, was teaching quantum mechanics to all sorts of physicists who didn't know it. And he came up with the Copenhagen interpretation to explain it. And so the Copenhagen interpretation is really good at, explaining how to calculate with quantum mechanics, et cetera. And the other thing Niels Bohr did with the Copenhagen interpretation is he added a layer of mysticism to it. So we'll try not to do that. But, good for teaching quantum mechanics. And what it says is that quantum mechanical processes, can be divided into two I don't want to say steps, but two kinds of evolution, something. Isolated processes undergo unitary evolution. And every so often, an experimenter, or maybe the universe itself, somebody looks at them, and this is called measurement. And it's awfully convenient to treat measurement as something that happens, something undergoes unitary evolution for a while, then it gets measured, then maybe it undergoes more evolution, unitary evolution, and then it gets measured, et cetera. Of course, in real life, these are happening both at once, and what you get is a master equation, and there are all sorts of, I don't know what the right word is. And you can look at master equations and figure out their dynamics and work with them, et cetera. But that's much more complicated, and this is the easy way to explain things. So this is what we're doing. So unitary evolution is what happens to quantum systems when they're isolated from the environment and nobody is looking at them.